Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Welcome to science lesson with me, Cikgu Roni. Yes, I am Cikgu Roni. If you can see here, if you can see clearly, that's Cikgu Roni. So, yes, I'm using a software to change my face whenever I want. You can check here, you can't check here, but I can always change my face into this one. See, or this one. Haha. But it doesn't really matter. So how are you today? I hope you are good. Fine. I hope you are excellent. Excellent is the word. So what we need to do is we need to learn two things. One is we need to recap about forces and movement and types of forces. And we shall learn in a new video, another video, part 2, a new topic which is about magnets. So let's go straight to the top. We can see here. We go straight to doa. Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Rabbi zidni ilma warzuqni fahma wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wa sallam walhamdulillahi rabbil alamin. Okay, our objective for today is to recap. In this video, we shall recap about our previous lesson that is about forces. And we also recap lessons about what forces can do. And we shall identify and check and identify different types of forces. And you will have exercises. I will give you exercises using Google Form. So let's recap. No, before that, step to success, I will talk about forces and you will listen. And I shall talk about what forces can do, and then you shall do exercises. So what is a force? What is a force? A force is a push or pull. So either push or pull is called force. A push means applying force on something to move it away from us. A pull means applying force on something to move it towards us or with us. Push means tolak, pull means tarik. But then look at this picture. What happened here? On the door it says pull, P-U-L-L, pull. Pull means tarik. But then this person is pushing the door away from him. So what is the problem? The problem is, I think the word here is wrong. It should be push, not pull. Okay, look at these examples of push and pull. There are many examples, but I will give you 3. Example 1 would be carrying a backpack. So when you carry your backpack, you are pulling the bag, not pushing. Pulling the bag, tarik, angkat, like that. You are pulling your bag towards you. Example number 2 is carrying shopping bags. So carrying shopping bags is also a pull. Example number three is peeling a potato or potato. Potato, it's the same. So when you peel a potato that way, like in the picture down here, so it's a push, you're pushing it away from you. So guess this one, this picture. Tell me, maybe one day you can tell me, or maybe in the comment, what movie is this from? This picture. What movie is that from? Okay. Next, what forces can do? Number one, a force can change the shape of an object. Example, playing Play-Doh. Example number two, pressing a ball. Here, pressing a ball, it's no longer round. And using a stress ball or pressing a stress ball is more or less the same. But using a stress ball, the stress ball will change shape when you press it. Now look at this video. Force can change the shape of a dough when making handball noodle. This is a short video, I think a few minutes. You can watch it with me. Look at how the person pushes the dough. And here the person is pulling the dough. And the noodle dough becomes longer and longer. So another question, why is this man or cook or chef is using lots of flour? The answer will be given in a few minutes. I will give the answer in a few minutes. So you can see here from dough to noodle, and the flour, just now lots of flour is used so the noodle won't stick to each other. Okay, we can skip this to the next lesson. Yummy, I will become hungry if I watch this again. Number two, a force can start an object to move from not moving. A force can start an object to move. Example like example 1, playing golf. The golf ball is not moving, but when the golf stick hits the ball, it's moving. Example number 2, bowling. Not the ball, but that one. It's standing there, and when the ball hits it, it moves away. And example 3, the ball that is not moving, football, is kicked and it is now moving. A force. Number two, a force can stop. No, number two. This is number three. A force can stop a moving object. Correction. This is number three. Number two would be a force can start an object to move. Number three, a force can stop a moving object. Example would be this. The first example is only fiction is in the movie Superman. And what happened in this movie is the bullet is shot right on his eyes. But then Superman is very strong. The bullet stopped there. The second example is more realistic, which is a goalkeeper saving a ball. See, you can see there the ball stopped. And example number three is falling on a net. So here there are two um, properties there, not properties. Not only the person who falls down on the net stop from falling even further, but when he hits it, it will slow down first. Slow down, then stop there. Slow down, then stop. It is not moving downwards anymore. Slow down, stop. Okay. Number three, number four, this is supposed to be number four. A force can change the direction of a moving object. Look at the example. Now, the boy is pulling his sister, and what happened is when the boy turns, the cart wants to turn too, but maybe he is too fast and the girl falls down and the cart overturns. It's the same with the vehicle here, accident. The truck is moving straight, but then when the, I think it's a red car, this car, that car hits the truck, it turns direction to this side. It's supposed to be go here, here, but then it moved that side, turns direction. So the third example is pushing a ball. The ball supposed to go in the net, but the goalkeeper push it out. It moves that way, like that. Okay. Number five, a force can change the speed of a moving object. Like I said, the previous picture about the guy who falls, a guy I think who falls on the net, it slows down, it's moving very fast, and then it slows down and stop and move different way. Now look at this example. A force can change the speed of a moving object. Example number one would be cycling. The faster you push, the faster you can go in your bicycle. Example number two, slowing down a space shuttle. When the space shuttle lands, they have emergency brake. It's not emergency, they have this kind of brakes, which is a parachute. A parachute can slow down the space shuttle when it is landing, like here in the picture, like that. And example number three is braking. So for braking, when your father or mother push the brakes with her feet, or bicycle is the same, when you press your brakes and the tires or the wheels of your brake of your bicycle, the wheels of the truck slows down. Okay, now I shall be explain about types of forces. There are a few types of forces that you need to recap. Number one is gravitational force. Now, our Earth have gravity. Gravity pulls things onto the surface of the Earth. The pulling action is called gravitational force. Gravity pulls us everything on Earth here. Tarik, it pulls like that. So we shall not fall into this space. Example of gravitational force that we use are here. Example 1, playing slides. This is a simple slide. There must be more example of slides, water slides, or some types of slides like this one. A simple slide uses gravitational force. Second example would be a falling cliff. If you see here, the cliff falls down, it is caused by gravitational force. Or example number 3, a falling ball. So everything in this world will fall on the surface of the earth. There are many more examples like falling fruits, falling apples, more examples, but the idea is the same. Gravitational force pulls everything to the surface of the earth. Now, next type of force is frictional force. Friction occurs whenever two surfaces rub against each other. Two surfaces like here, the two surface, dua permukaan. Two surface means the surface of the box and the floor. Here, force can slow down a moving object. Friction can slow down a moving object. Friction can stop a moving object. Friction can help us and objects to move properly. And point number 5, if we do not have friction, we will slide. Everything will slide. Now let's look at the examples. Here is slide. The girl is playing slide, but she places her shoes first, like that. Shoes, look here properly. Look. And shoes and plastic causes friction, and she falls down. She does not slide anymore here. Look there. Another example would be walking. Walking uses friction. And what happened? The road or the pavement or the floor or anything that you step on will have friction against the shoes that you are wearing, like here. And it will help you to move forwards. It's the same like running, and running is faster than walking. The same idea. Look at this example with no friction. This is frictionless. If you do not have friction, this would happen, like this man holding a fish. Because the fish is slippery and there is no friction, the fish falls from his hands. He cannot hold the fish properly. If you have a bottle, this is not promoted by Mr. Brown, but between my finger and this bottle, we have friction and the bottle cannot move. Here, it is not slipping from my hands at the friction here. Here. Okay. here. See, friction is between my fingers and this bottle of Mr. Brown coffee. So another example is sliding car. The car wants to move forward, but what happened is there's no grip. They say no grip or no friction, and the car slides like here in the picture. The third example is walking on ice. You cannot walk on ice like normal walking or normal shoes because it is too slippery, no friction, frictionless. So sometimes if you check, sometimes there are objects that you have, they make something on it so you can handle it properly. Example, this, if you see this, there are something like this one. This helps us, this create friction, this creates friction, and it will help us to hold the bottle, the cap properly, so we can open it or close it. It's the same like this bottle. It's the same like your shoes. It is made from rubber. So rubber creates have friction. When you use rubber, it is better. You can hold it better. Like your pen, you have rubber covering on the pen so you can hold it properly. It's not slippery, so you can have friction is there using rubber. Now next type of force is magnetic force. As you can understand, magnetic attract things made of iron. This is iron. And steel, this is steel. Steel is a mixture of iron and some other alloy. That's an alloy, other types of metal. It will become still stronger than iron. This force of attraction is called magnetic force. So a magnet attracts things made of iron and steel. It is called magnetic force. Example, lodestone. Lodestone are naturally magnetized rock. So there are types of rocks called lodestone. It is magnetic naturally. Example number 2, magnets on bags or handbags. You can check your mother's handbags, or I think in some of your bags you will find magnets on the bag, so it can help you to close your bags, or your mother can close their handbags properly. And another example, you are using magnetic force every day would be magnetic boards, or like the duster in our school, or the magnets, or the fridge magnets at your home. Those are things that you use magnetic force every day. So the next force is elastic force. So elastic force you have here is rubber bands is elastic, springs are elastic. Rubber bands are elastic, springs are elastic. Uses elastic force uses flexible objects to create a force called elastic force. The best example would be these two, and you use these two things in many things at home. The second example would be your pen. Inside your pen, you have springs, and these springs, when you push it, it will have elastic force. Another example you might not have at home would be trampoline. I do not have trampoline. My neighbor have trampoline, and his children is jumping around on the trampoline. The third example is here using bows and arrows. Now the question is, which part of the bow is elastic? The bow part, not the string part. If you look here, this part is elastic, this one, not the string. The string is not elastic, only the bow. And this uses, oh sorry, not magnetic force, elastic force. Example of, one more time, elastic force. I'm sorry about that. Next, exercise. So you will have a link. This is the Google Form link. I will also post the Google Form link under the YouTube channel in the description, and also from your teachers group. I will give the links to them, both the YouTube links, this YouTube links, and the Google Form links, and you will answer in here. You will answer di sana in the form. So to make it easy, please prepare a pencil and a piece of paper. Study the pictures and choose the answer properly. Click the link provided and fill in your selected answer into the Google Form provided. I will give you exercise now. Now I will give you exercise. You write using a pencil. Example 1, question 1, number 1, or number 2, or number 3. So later, using the Google Form, you will just fill in the answers that you have written. The question is here in this video. Okay, we shall start now. Question number 1. Study the pictures and identify what force is used. Here, look here, smashing a phone. Smashing a phone using what? What happened here? There are two metals, or two types of metals, and it is moving towards each other. So is this gravitational force, friction, magnetic, or elastic force? Question number 2. Jumping into a pool. Is it 1, 2, 3 gravitational, frictional, magnetic, or elastic? Here jumping here, not that one, here, this one, that one. Is it 1, 2, 3, or 4 gravitational, frictional, magnetic, or elastic? Question 3. Waterfall. The water is falling into the river. Is it gravitational, frictional, magnetic, or elastic? Question 4. A moving car. The car is moving. This F1 car is moving forward. Is it gravitational, frictional, magnetic, or elastic? What helps the car to move very fast like that? Next question, question 5. Stress ball. Is it gravitational, frictional, magnetic, or elastic? Question 6. Car lift. Lift a car using this special thing. Is it gravitational, frictional, magnetic, or elastic? Next, push button switches, not the type like your home button switch for your light. No, this is different. This is push button switches. So push button switches, is it gravitational, frictional, magnetic, or elastic? Next, wooden pegs. You have this at home. So this is gravitational, frictional, magnetic, or elastic. Question 9. Hand beaded toilet spray. This one I pointed with arrow. When you press this, it will go, the water will go out. So this thing, what force is used here? Gravitational, frictional, magnetic, or elastic? And question number 10. Phone on a tilted table. The phone do not slide, is staying there. So what helps the phone to stay there? Gravitational, frictional, magnetic, or elastic? So that are the 10 questions for part 1, exercise part 1. For this video, that are the 10 questions. So to finish our video, we shall recap. Number 1, force is a push or pull. Recap 2, a push is to move something away from us. A pull is to move something closer with us. Recap the 3, a force can the shape change the shape of an object. A force can start an object to move. Sorry. A force can stop a moving object. A force can change direction of a moving object. And a force can change the speed of an object. And recap number 4, there are 4 types of forces: gravitational force, frictional force, magnetic force, and elastic force. Gravitational like slide, frictional like walking, magnetic like fridge magnets, and elastic force like your pen. Thank you for watching this video, and we shall continue on part 2 about magnets. See you later. Assalamualaikum warahmatullahi wabarakatuh.